So this is where we ended off on Tuesday. So we're going to sort of finish up our linear sequences this evening, and then we're going to start looking at quadratic sequences. That's sort of our game plan for tonight. And we will see how we go. The important thing to remember of what we did last week is this dude over here. That is how we find our general term of a sequence that is linear. Okay, so if we have a look at the sequence, we're going 25, 19, 13, 7. So what is my common difference? What is my common difference? Good. Is it going to be 6 though? I like the number. I just need something else. Where's the 1 coming from, Yanda? It's going to be -6. So to get from the one to the next, we are subtracting 6 each time. So our common difference here is going to be -6. And with our linear sequences, that negative or positive is really important. It changes everything. So if our numbers are going down, make sure that it is a negative. If they're going up, it is a positive. So just be careful that you have got that. Okay. We are one. Oh, Yanda, I see what you're saying now. It's like, what on earth? Where is this 1 coming from? Yes, I very much agree with that, but the next term would be 1. Okay, we are trying to figure out what position the next term would be of the number that is less than -100. So we're going to be using our formula that we spoke about on Tuesday. And I want you to treat this -100 as your Tn. You can tell me what your A is. What is your A? So A is your first term of the sequence. -25. And our common difference here is -6. So your first goal is to work out your Tn situation. And then you're going to make Tn equal to -100. And you're going to get some numbers. So I want to know, what is the position of the first term that is less than -100? To give this one a go, I will give you some time to ponder it over. So first work out your general rule, your general formula, and then substitute Tn as -100. And well done, everyone, for being here on your holiday. I am very proud of you. That is hard work. Hello to those of you who just joined. Okay, I'm going to give you 2 more minutes on this one, and then I'm going to start talking through it. Haha, Uyanda. Good. I'm glad that you got a decimal. Yes, your one part of your answer is a decimal, but your final answer will not be a decimal. Because you got to read the question carefully. Okay. Let's have a look. So let's first work out our general formula or our general rule. So Tn is equal to 25 plus n minus 1 times negative 6. And now remember, we're going to multiply that negative 6 into both of those. Okay, so we get Tn is equal to 25 minus 6n plus 6. So Tn is equal to negative 6n plus 31. So that is our general rule or our general formula. Cool. Now we can start playing with this negative 100. Okay, so let's sub that in. So we're going to make the Tn negative 100. Negative 100 is equal to negative 6n plus 31. So negative 131 is equal to negative 6n, which means that n would be 21,83 something, something, something. Some funny number. Okay. But we can see in our sequence that our numbers are getting smaller and smaller and smaller and smaller, right? They're asking you, what is the position of the first term that is less than negative 100? So we know that term 21, if we substituted that in, so let's took this, term 21, if we put that into our formula, oh, sorry, not an n. Term 21 would be negative 6 times 21 plus 31. Woo! Can someone pop that in their calculator for me? Please. Negative 120. Thank you. Thank you. And if we subtract another 6, we would get so if we were on negative 95 and we subtracted 6, we would get negative 101, which would be the position of the first term that is less than negative 100. So this is telling me that term 21 is going to be somewhere around there, because exactly at 21,83, I would get to negative 100. But the first term that would be less than that would be term 22. And if you ever need to check yourself, you can always sub it in. So here we just subbed in term 21 and we saw that was negative 95. If we subbed in term 22, we'll see that that is negative 101, and then you'll be able to see that that is less than negative 100. So you can always use substitution when you need to. Abu, what is up with your patterns? They are stumping you in a weird way. Okay. Take a screenshot if you would like. This is the answer we care about. And then we'll try our next question. Next question is our last question on linear sequences, and then we're going to jump into quadratic. Okay. So we have a sequence, 3x plus 1, 2x, and 3x minus 7. And they are the first 3 terms of a linear number pattern. So this is term 1, term 2, term 3. You need to determine x. What is the one thing we know about a linear number pattern? What is something that we know will always be the case in a linear number pattern? Good. It will always have a constant difference, always. So if I had term 3 minus term 2, it will always be the same as term 2 minus term 1. And that is my hint to you. And now you can solve for x. Hi. So it's not what I got. But it doesn't mean you're wrong, because I could have made a mistake. I think something might be happening with your brackets. Let's try. So this is term 1. This is term 2. That's term 3. Does that help? What else would it be? It's a whole term. 3, I don't know. Okay, so we're gonna follow on from this. So we're gonna say term 3 is 3x minus 7 minus 2x. And we're saying that that's equal to 2x minus 3x plus 1. So I'm just going to simplify this side. I've got 3x minus 2x, which is just going to give me x minus 7. And then over here, I have 2x minus 3x minus 1. So I have x minus 7 on the left and negative x minus 1 on the right. I'm going to move my x over and my 7 over. So I have 2x is equal to 6, which means x is equal to 3. And you can always substitute to check. So if x was 3, we would have 3 times 3 plus 1, which gives us 10. 2 times 3, which gives us 6. And then 3 times 3 minus 7, which would give us 2. And you can see we are minusing 4 each time. So then we know we're right. Ah, so Yandi, you didn't distribute this negative into that one. Fair enough. Okay. If you would like a screenshot, please feel free to take one. And then we're going to move into quadratic. No, you'll be fine. What we'll do next week is we'll just do questions until we're feeling good with these. Don't panic. Okay. Okay. Quadratic patterns, so quadratic sequences. When we have a quadratic, that's our parabola. And we know that a quadratic expression or equation is always going to be an squared plus bn plus c. So we're going to have something x squared, something x, and then a constant, right? So if you think about your trinomials, that's pretty much consistent with that. So something x squared, something x, and then a constant. So that's generally what we have for a quadratic. That isn't to work out our general formula. That is just the general equation of a quadratic sequence. So if we were given this sequence, so we were told Tn is equal to 2n squared plus n minus 3. And we had to write down the first 4 terms of that sequence. I would like you to work out what those would be. So you're going to work out when n is 1, when n is 2, when n is 3, and n is 4. Yeah, parabola. Parabolas are your quadratic equation. So the same way that a linear A linear sequence is a straight line. A quadratic sequence is a parabola. That's why your parabolas are always quadratic equations. That's why there's always an x squared. I'm just going to quickly turn on my light, guys. I will be 2 seconds. Yeah, I like those numbers a bit. Cool. So we've got term 1, term 2. We'll have 2 times 2 squared plus 2 minus 3. And that's going to give us 7. Term 3, we're going to have 2 times 3 squared plus 3 minus 3, which gives us 18. And term 4, 2 times 4 squared plus 4 minus 3, which is equal to 33. Okay, cool. So next thing I'm asking is, can you determine the difference between each term? So this is called the first difference in quadratic sequences. So our terms right now are 0, 7, 18, 33. Those are our current terms. And you are going to work out what the first differences are between those terms. Good. Good. Oh, I just hit my funny bone. Oh, that hurts. Oh my goodness. Okay. Sorry. So if I have a look here, it's fine. 7, and then 11, and then 15. So this is my first difference. Cool. Next, you're going to do is you're going to work out the second difference. So the second difference is going to be from those two. That's what the second difference is going to be. Yeah. Isn't that pretty cool? The second difference is 4. The second difference stays the same. Pretty cool, right? And this is the cool thing about quadratic formulas, is that the first difference of a quadratic sequence creates a linear sequence, and the second difference is therefore going to always give us a constant difference. So the second difference is the same, will always be the same. Always, every time. And we're going to use that knowledge to help us solve things. Okay, so take a screenshot if you would like. And then we're going to figure out a formula to figure out the general term of a quadratic sequence. Okay. Okay, so the question is now, can we work out a formula for the general term of a quadratic sequence? So the general form would be Tn equals an squared plus bn plus c. Cool. So let's use this and work with terms. So let's do term 1, term 2, term 3. And we're going to use this dude over here. So for term 1, we're going to make our n's equal to 1. So a times 1 squared plus b times 1 plus c. That's term 1. So term 1 is going to be a plus b plus c. Happy? Okay. Term 2. A times 2 squared plus b times 2 plus c. So I'm going to have 4a plus 2b plus c. And then for term 3, I'm going to have a times 3 squared plus b times 3 plus c. And I'm going to land up with 9a plus 3b plus c. Okay. So that is my quadratic sequence. This is term 1. This is term 2. This is term 3. So what would my first differences be? Can you work that out for me? Good. So 4a minus a would give us 3a. 2b minus b would give me b. And then the c's would cancel. All right, so that's what that would be. And here we have 9a minus 4a, which would give me 5a. 3b minus 2b, which would give me b. And then my c's would cancel. Okay, so that's my first difference. And then we're going to go down another level to our second difference. And what would that be? Yeah, good. 2a, solid. Promise this is all going to make sense in time. Okay. So what we're going to take is we're going to take this dude for our first difference, and we're going to take this dude for our second difference, and we're going to play with it a little bit. So the sequence that we worked on just now, I'm going to write those out again. The numbers were 0, 7, 18, 33. Okay. Our first differences were 7, 11, 15, and then our second differences were 4. Okay. So if we took the first difference and said that 3a plus b needs to equal this one, because see, that first difference, that's what that was equal to. Let's see what that gives us. So 3a plus b needs to equal 7. Cool. And then we've got the second difference. So 2a needs to equal that dude. So we know 2a needs to equal 4. So that means that a is going to equal 2. And here, we now know what a is. So now we know that this is going to be 3 times 2 plus b, which is equal to 7. So b is going to equal 1. So now we know the first part. Then we go all the way to the top where we've got our a plus b plus c. It's pretty cool, right? So then we go all the way to this top one over here, where we've got a plus b plus c. And we know that that is our first term, which for us was 0. So then we can say, cool, a plus b plus c equals 0. We know a is 2, we know b is 1, and we don't know c yet. So that means c is going to be -3. And that means that our formula is going to be Tn equals a 2n squared plus b plus 1n plus c. And that is our quadratic formula. Yay. So this can get confusing. So I like to think of it as steps. So you don't need to remember that. That is to understand why we use the formula we use. What I'm about to write next, you do need to remember. So I like to think of it as steps like this. So we have first term, first difference, and then second difference. First term, you're always going to have a plus b plus c. First difference is always going to be 3a plus b, and second difference is always going to be 2a. And if you can remember these steps, you will always be able to solve any quadratic sequence. No, generally. It's always going to be that every single time. If you remember those steps, you're always going to be fine, I promise. And it works best to work from the bottom step up. But take a screenshot of this and then we'll do an example. we'll do an example. Yeah, absolutely. Okay. So let's try and put this into work. First thing I'm going to do, whenever I have a quadratic sequence, so if my question has a quadratic sequence in it, the first thing I'm going to do is I'm going to draw my steps. A plus B plus C. 3A plus B, 2A. Okay. Then I'm going to think about what my different numbers are here. So I'm going to work out what my first differences are. So I have 4, and then 10, and then 16, and then 6. And like we said before, we care about the term 1, we care about the first difference, and then we care about the second difference. So we care about this number, that's term 1. We care about this number, that's my first difference. And we care about this number, it's my second difference. Okay, so using that and using your steps over here, I would like you to find the general term for this equation. A boo, I am not hating that answer. I am a little bit confused about your C though. I really like your A and your B. Oh, you know what you've done is you've made it equal to 0, but your first term isn't 0. Your first term is 5. So where you've written this line over here, this is always going to be equal to whatever the first term of your sequence is. So my first term is 5, which means it's going to be A plus B plus C is equal to 5. And yours is equal to 0. There we go. So it's always easiest to start at the bottom step and move your way up. So we start with our second differences. So 2a is equal to 6, which means a is equal to 3. And then we move to our second step. 3a plus b is equal to 4. So 3 times 3 plus b is equal to 4. 9 plus b is equal to 4, which means b is equal to -5. And then top step, a plus b plus c is equal to 5. So 3 minus 5 plus c is equal to 5. -2 plus c equals 5, which means c is equal to 7. So Tn is going to equal 3n squared minus 5n plus 7. There you go. Got to go from the floor and rise back up. And that's a quadratic sequence. Isn't that pretty cool? And now you could also plot this and you would have a nice parabola. We could do completing the square situation if we wanted to, because now we're geniuses. Okay, take a screenshot if you would like. And I would like you to do this one for me from scratch, so with no help from me. Okay, I'm going to give you 2 more minutes. coriander, keeping us on our toes. All right. So, first step, I've got to figure out what my first difference is. So how have I gone from -5 to -15? I have subtracted 10. Then I need to get my next one. So how did I get from -15 to -29? What would I have to subtract to get from -15 to -29? I'd need to subtract another 14. Are we happy so far? Which means so that's my first difference, which means my second difference is how do I get from -10 to -14? I subtracted 4. So my first term is -5. My second term, or my first difference is -10, and my second difference is -4. And then we can work our way up. So 2a equals -4, which means a is equal to -2. 3a plus b is equal to -10. So -6 plus b equals -10, which means b is equal to -4. A plus b plus c is equal to -5. -2 minus 4 plus c equals -5, which means c is equal to 1. So therefore, Tn is equal to -2n squared minus 4n plus 1. Take a screenshot if you would like. And I think let's try do one more question for the night, and then you can turn your brains off for the whole weekend because you're on holiday. That's good, Abu. As long as like that's how we learn. So that's good. Okay. Let's see if we can all get this one right. You know, Abu, there's lots of studies that show that your brain learns things more effectively through making mistakes. So first difference is 1 and then 3. Second difference, 2. The numbers we care about, 2, 1, 2. 2, 1, 2. Work our way from the bottom up. So 2a is equal to 2, which means a is equal to 1. 3a plus b is equal to 1, which means 3 plus b equals 1. So b equals -2. A plus b plus c equals 2. The 1 minus 2 plus c equals 2. So c is equal to 3. So my general term is going to be 1n squared minus 2n plus 3. Okay, so now my question is, which term is equal to 1,683? So what is n if Tn is equal to 1683? I'm going to give you a little more time, and then we'll talk this one through. Look at you, boo. I'm not hating that. Yeah. Exactly. It's just factorizing. So we're trying to see which term would be equal to 1,683. Okay, so if I put this into my formula, so we have Tn is equal to n squared minus 2n plus 3. We've worked that out already. We know Tn is going to be 1683. And that's going to equal this quadratic. Okay. So I'm going to move everything to one side so it's equal to 0. Now you can use the quadratic formula here because this is a really nasty question to try and factorize, but it does actually factorize quite well. So we land up with -42 and +40. So when we multiply those together, we're going to get 1680, but you always are welcome to use the quadratic formula if you are wanting to. So what we're doing here is we are factorizing. So we land up with n minus 42 and n plus 40. And so therefore n would be 42 or n would be negative 40. Now, why am I getting two answers for n? Why do I have two answers for n? Because it's a quadratic. Yes, it is a quadratic. Let's say that this number over here is our 1680. It is going to happen at two different points because it is a quadratic. But because they're asking us which term, we can't have negative terms. So we can't have a negative number for a term. So that means we can't include this one. So we're going to say, well, n can't equal negative 40. Therefore, it's going to be term 42. Yay!